Well, this is it. You guys have seen me post about this for the better part of a few months, albeit this project has been going on for nearly 3 years at this point, in some form or another. But this is it. This is the M44 BP bastard child. You know, BMW M44 head, Mazda 1.8 liter BP block, coming together as one weird, strange combo. I'm going to take a little bit of time to explain kind of how all this goes together today, where the project is at, where the project is going to go, and I have some questions that I'm going to answer from the little Q&A poll that I had put up on Instagram a couple days ago. So stick around. The first half is going to be me doing all the technical talk on this. I'll try not to go too far into the weeds, but other than that, the second half is going to be the Q&A. If you feel like you want to watch the Q&A, I'll try and put a little marker for everyone to be able to skip ahead. Yeah, otherwise, stick around and enjoy.
She lazy in Miami, got the hoes. Texas got the ladies, and you know we turning up. You can never play me, don't shady. I can't save you, you can't see me, you can't feel me. In New York, I'm acting crazy. LA, bitch, she lazy in Miami, got the hoes. Texas got the ladies, and you know we turning up. You can never play me, don't move shady. I can't save you, you can't see me, you can't feel me.
So now let's start on the why, the obvious elephant in the room. You know, you think about cylinder head swaps and this and that, and everyone thinks more performance. I'm not going to deny that's a small aspect of this, but generally speaking, that's not my main motivator. You know, my normal 9 to 5, I do mechanical engineering and materials testing. So basically, you make it, we break it. I like to think I have a decent grasp of design, materials properties, that sort of stuff. So I come into this project with a little bit of professional understanding. That being said, you know, my main driver is the fact that I get to come home and play with Miatas. You know, doing something like this is a fantastic challenge. It's not something that you can necessarily find on a forum, you know, to get all your answers to. You have to put in the work to do it. You know, I'm not going to find this valve cover anywhere else. I had to make this. I had to do and understand every bit of design work that went into it. The PCV system, you know, where I want my oil cap even to go. All those things are, it sounds dumb when you hear it, but you have to think about all of it. You know, the M44 is originally a timing chain motor. Well, in order for us to do this, to use the factory Mazda timing belt system, you know, we have to cut off the whole front end and make a delete plate so none of the oil comes pouring out the front. All these little factors that start building together to get something really cool and unique. And so my whole driving motivator behind this project is actually just to say I did something like this. You know, if it runs, fantastic, huge check mark, you know, done on the figurative list. You know, if it makes more power over a stock BP, fantastic. If it can eventually become a kit that people can go and source an M44 head and use and do something like this, great. But these are all secondary and tertiary elements to what I would really say is just my desire to challenge myself, to challenge me, to challenge my mind, to challenge my ability as an engineer. So first and foremost, that is really what this project is about. Just doing something cool for the sake of me. And you guys get to be along for the process, and I find that is a really cool thing too, just because there's so many different little communities coming together to watch what the hell happens with this thing, because even I'm not sure what is going to happen, what power it's going to make, if it even runs at all by the time it's all said and done. That's cool. There's something very special about the unknown, and I like it. Now on to a little bit of the technical side. Bear with me. I'm sorry if I lose some of you. I'll try and keep it pretty clean cut and self-explanatory. But again, I apologize in advance if I lose some of you. So the M44 in itself, as I mentioned before, is a timing chain motor. You know, as part of the process, all of that has to be eliminated in order to go to the Mazda timing belt system. Originally, I tried to figure out a way to adapt it without modifying the cylinder head in any way. It's something that makes it very affordable at that point when you don't have to modify anything existing at that level. Unfortunately, none of the factory stuff from Mazda would be able to fit in place. There's a big curvature that actually comes off the cylinder head in the factory M44 setting where the front timing cover then goes on. And there's no way to cleanly seal up the cylinder head without really building a whole delete plate like we did. So this cylinder head was taken to a local wire EDM shop. We told them to take it back until we have a nice perpendicular surface from the head gasket face, have everything very squared so that when this timing plate goes on, we can run sealant, hold the entire oiling system within the cylinder head, not having it pour out, to lubricate the timing chain, what would normally happen. And then we've integrated a seal between the valve cover and the timing plate to then seal those portions together. So that's the biggest challenge coming into this, is making sure all of that can be built in a way that oiling system is safe and usable. But then you get into the little nitty-gritty details. You guys have seen me struggle with this timing belt probably for the better part of 3 months. I'm not going to pull them out on camera, but I probably have 5 or 6 different timing belts sitting around the shop until I finally landed on this one. This is a stock 2JZ timing belt, from your SE300s, GS300s, Mark IV Supras. And it happens to be perfect to utilize the stock Miata cam gears and the stock Miata crank pulley. I did have Mazda Protege parts, these tiny little guys, that I wanted to use just to keep everything a little bit more compact. But honestly, the Miata setup ends up working out better anyhow. Again, going back to like the swap kit mentality, you'd already have these laying around. You don't have to go source something from Protege in order to do this then. It saves you some money. It is on order, it just hasn't arrived yet. I did source a slightly larger pulley here, so we have a little bit more idler tension adjustment. It'll reflect closer to what you would expect out of a stock, BP tensioner if you had a Miata timing belt and cylinder head and everything as part of it. So this is something that will be changing after the video. And the next big challenge after that, honestly, is cylinder head oiling. Your cylinder head is fed by a little pressurized port between cylinders 2 and 3. The M44 and the BP both happen to share cylinder head oiling between cylinders 2 and 3. And I forget which has it on which side, but both of them end up feeding from, their respective sides between cylinder 2 and 3. They just happen to be opposed to each other. So I would have to go and look at a block. I forget off the top of my head. But if we say that on the BP it feeds off of the exhaust side between cylinders 2 and 3, well, it would do the same on the M44, but because the M44 and the BP are opposing flow, now it becomes the opposite side. So unfortunately, I've had to make an external route for this oil pressure to reach the cylinder head, which I'm actually just using a concept similar to what you do when you feed a turbo. You can tee off the BP's factory oil pressure switch, and part of the design that I did for the feed in the back of the cylinder head brings to mind that you have a small feed port when it comes to keeping the high pressure into the cylinder head, and the diameters that I used in that feed fitting reflect that. So that way we're not losing any of the thought that either Mazda as an OEM or BMW as an OEM had put into those feeds. We're just feeding it from a different location. Instead of it coming up between cylinders 2 and 3 and spreading outward to cylinders 2, 3, and 1 and 4 at the extremes, we're just feeding it from the back forward. Is there a little bit of a danger of potentially losing pressure all the way up at cylinder number 1 for the cam journals? I'm not going to deny it. There's a chance it could be that you would have favoritism of pressure, towards the back in cylinders 3 and 4 versus up front in 2 and 3. That being said, there's other cylinder heads that I have seen that have fed from different locations and, feed through camshafts and this and that. They don't really have any issues otherwise. It's a pretty safe gamble that I'm willing to take, essentially, as part of this process. All right, so let's get a little bit more in depth in here. I've taken apart some of the front end of this, loosened up the valve cover so we can get into some of the internals and really see what sets this apart from a stock M44. So first and foremost, this is the kind of like V1 front timing plate. There's a lot of this that's going to change in the near future, but this is a representation of really, the one major thing that you have to do to make this work. As I mentioned before, you have little end pieces here that come off of the stock M44, and when we pull this away, we can see all of these oil passages up in here because of the cams that would normally pour down into your timing chain. In addition to that, these two passages here are for coolant, and this one little cutaway here actually normally goes to your timing chain tensioner. It'll be like a little valve body here on the side, and you run oil pressure from the first cam cap through here to that tensioner, and so now we just have this open channel. The big thing that has to be thought of is how are you going to seal it all? And so we have these passages that are going to seal up with RTV to seal up against these nice machine surfaces here. If a little bit of oil gets into these areas, not too big of a deal, as long as nothing really drips out. That's the big thing. Sealing in our coolant is really the main thing, along with the oil as part of all that. So there's extra emphasis on sealing around these major mating surfaces and kind of this general area up here to keep the oil where we want it. The big one that can kind of mimic a blown head gasket, not getting oil from the cylinder head into our cooling passages. Again, this is the version 1 of this assembly. There's literally one securing point that you can see over here. By the time this is all said and done with a sort of a final iteration, before we run this, there will be mounts coming off the cam caps right up here. They're threaded sections. There'll be brackets built to help support this and really, clamp it into place, help support that RTV and seal in the assembly as a whole. So one small nuanced detail I want to address is this camshaft setup that you're seeing right now. This is not reflective of anything final. This is actually just to allow me to do some work, especially when we're developing the timing plate, to have the cam gears in a representative location to where the stock Miata gears would be in comparison. So, we're not making our own camshaft as part of this. But I do want to show this. So the factory M44 camshaft has this square sort of looking mounting surface. And as part of this whole process, we're actually going to have to cut back this whole, square area and almost up until the journal in order to modify it to allow the factory gear to slip over like so. So obviously you can see that this ain't gonna work. So this is just a printed representation of the final form that this is going to take at the end of it all. We'll work out a way, just because there's some additions of material that we need to do. We need to tap the center for the appropriate thread for this bolt. But there's no reason that the print can't help us have a accurate representation of what will be final form. So it's not something that was commonly asked as a question, but it is something I wanted to bring up while I had all this blown apart. The next big element is the valve cover itself, and I'll be very careful to handle this. It is technically two pieces right now because of the size of my printer. I use a Bamboo X1C, but this guy is all designed in-house by yours truly. Some of the aesthetic inspiration comes from Hart racing engines from 1970s, 1980s Formula One. Along with the factory, M44 valve cover. This rib style is super common. These are the NB2 coil packs that will run with the NB1 ECU. And then right now I just have a normal Miata PCV in here from every other, 1.6 and a 1.8 except for the BP4W. The BP4W has like a 90-degree bend. We're more than likely going to run the BP4W PCV just to route the vacuum hoses a bit nicer. And then when we flip to the inside, and hopefully I don't drop any of this, you can see a lot of our sealing surfaces. Again, it's going to use that same little ridge like what we had on the front timing plate to allow us to seal up against the valve cover to the cylinder head. You can see some of the open channels in there where your oil would flow for the PCV system, kind of up in here and up in here. along with a little redirect down here, that when you go and fill your oil, it's not going to pour into this front area and kind of pool there. This is actually going to have a little ramp, and it will force oil closer to one of the like oil drain returns in the cylinder head. And now the final little cool piece with part of the swap. So as you can see here, and as mentioned before, this cylinder head needs to have oil flowing to it. I think that's pretty obvious. But we don't have oil feeds in the head that actually align with the oil feeds from the block. So the only way that we can actually supply oil to the head is via a feed like this. It's an external route feed. So kind of the same way you oil a turbo, we're using the same concept here to supply oil to the cylinder head. And so I have a little cutaway print to show everyone that maybe can't visualize it themselves, how the oil flows. So it is a little bit mirrored, but oil will come up through this feed line from the oil pressure sensor on the side of the block. It will enter the block. There will be a set screw here because of how it needs to be machined. It'll come up and then it'll distribute evenly side to side because you're hitting a T. There are nuanced details where maybe one side gets a tiny bit more pressure than the other, but generally speaking, operating off of this uniform principle, we should be okay and get equal support between the intake and the exhaust side. But it's just a nifty little piece utilizing factory drilled holes that end up, feeding these journals anyhow during the machining process. It's how they end up drilling the feeds themselves, but then capping them off at the end. And now we're using it to supply the head for this project. So it is a neat and simple little piece of the swap. But something that has to be done, and I like the fact that this is done in such a simple way that it makes it really easy to do and a very affordable thing. It's not like some kind of crazy remachine to feed the head. So hopefully all that gives you guys a better understanding of what's going on here with the swap. In certain aspects it's very straightforward. In other senses, it does take a lot of thought. The wire EDM work in the front, the timing plate, designing the valve cover. It's all stuff that really has to be thought out. It's not off-the-shelf stuff, for very obvious reasons. But that's what makes it cool. And so hopefully any questions that you guys have further on will be answered in the Q&A coming up. And if there's anything else that you want me to go over in the future, feel free to reach out on Instagram, reach out in the comment section here, and I'll be happy to answer it. But enjoy the Q&A. And now to the fun part, honestly. I'm glad I didn't get too many questions on this, and some of these were already slightly answered throughout this video already, so sorry if you're hearing certain things again as like little reiterations and this and that, but a lot of these are really good questions and I don't want to ignore them, especially because people keep pestering me about compression ratio. I have a whole list that I've put together now on a sticky note just to answer this question, not because I'm necessarily tired of hearing it, but because in a way, there's certain unknowns that finally I just had to sit down and go, all right, I can at least ballpark some of this so people can stop asking me this question. And so I'm going to go through a couple of these now, and hopefully questions in the future will be a little bit more technical, or, will be in reference to newer information, as this project develops. I don't have to reiterate a lot of old stuff. What was a driving motive to do this project? I enjoy the coverage of it. You heard it really early on, I'm doing this for me. At the end of the day, I get to come play with Miatas. I wanted the mental challenge of getting to do all this, the engineering challenge, being resourceful. People love saving money when it comes to big business. And, even me in my small business, like, no one wants to spend money if they don't have to. So being resourceful is really cool when it comes to this project, to see how much, even with such a wild concept, can be bought off the shelf. So yeah, personal drive and resourcefulness are the big motivating factors. The use case for this mod and things like that, that's from my buddy Augie. We kind of went over some of the benefits and use case. If it makes more power, cool, great use case in that regard. You know, a bunch of people chuck away M42s and M44s. I picked up both cylinder heads that I'm using for R&D for $200. There's some people that are crazy and try and sell it for like $1,200 for whatever reason, but I bought a full M44 that's sitting in my side yard for $250. You know, there's a lot of cheap M44 parts to be had, and it makes it a really cool, viable option should something work out. From my buddy Kevin, you know, won't the printed parts melt immediately? So, technically speaking, if I leave PLA, yes, it's pretty straightforward. All the parts that you see up here, these are all mock components. At absolute best, my plan, and I should have addressed this honestly, like, you know, in the going forward part of this video, but my plan is to essentially leave all of these basically subpar quality prints right until we're ready to turnkey with this engine on a stand. You know, these parts can handle oil for 20 or 30 seconds for me to confirm that I don't have some, you know, crazy leak or something I didn't think about. You know, it's thinking again about that budget side of all of this, that I don't want to waste money in places I don't have to. So, you know, as soon as we realize that this thing can fire off, that, you know, it is really viable on the stand, then a lot of these parts are going to get remade. You know, this valve cover is going to be printed in Ultem. Ultem is extremely high temperature resistant plastic. It's oil resistant. You know, this front timing cover is going to go from, you know, just this average PLA or PETG, I forget what this ended up being, to probably, you know, a nice piece of CNC'd aluminum. So that way we have a better clamping area, you know, more square to the cylinder head casting. Like I mentioned earlier, you know, we'll have certain sheet metal components that are already inside the valve cover. The oil feed in the back of the head will already be, you know, a nice CNC'd aluminum piece. So the prints really right now are here for mocking purposes. You know, they're not, this is not the final form by any means. RPM range and BP architecture affecting this. You know, because this is supposed to be, you know, kind of going into a little bit of the engineering side of this, you know, outside of me wanting to do this for personal proof, you know, I would like to do a stock-to-stock comparison. I think that's the you know, most respectful way to go about doing this, is that I don't want to tell someone a power figure and all of a sudden it's because, you know, we're 2 to 3 times like on compression ratio bump. You know, I don't want to do a comparison where the stock Miata motor is at 10 to 1 and this thing's making 12 or 13 to 1 compression and say that, yeah, the cylinder head did this. It's not. The compression ratio did that. It's not because of the architecture of the cylinder head. So with respect to that, you know, I also want to keep the RPM range the same. The factory ECU is obviously keeping that in line, you know, when that test start comes. But even in installed iterations, you know, if this motor ends up going in a car, I want that first iteration to be with a factory red line, with as close to factory compression ratio as we can get, to have a true comparative test. So that's where some of that stands. In just, you know, being fair and being scientific about it. You know, what are the cost of parts alone, not the R&D, etc.? How straightforward is the swap? I think at this point, you guys understand how straightforward or lack thereof that the swap is. You know, if you're creative enough, if you have a bit of an engineering background, I don't think it's anything too complex to do. You know, you need to be resourceful to do it. In terms of it being a swap kit, you know, it would probably be something that would be very hands-on for someone. There's certain elements that might change, you know, depending cylinder head to cylinder head. And that's why I'm very skeptical about making it a kit to offer right off the bat. You know, A, for cost purposes, but also B, just, you know, I don't know the variability in these BMW cylinder heads yet. I don't know what tolerancing we need to really worry about, because at the end of the day, cast parts aren't necessarily the most accurate. And because of that, you know, I don't want to leave anyone stranded and out of a bunch of money. You know, that's just being fair to me, to customers, and to enthusiasts as a whole. You know, I don't want to screw people, plain and simple. So Cost to me so far, I spent $200 between two cylinder heads, $250 on a full M44 that I have sitting in case I needed referential information. Um, Little odds and ends between timing belts and pulleys and thermostats and this and that. Like that's and the fittings that you might see laying around here. Probably another like $200 to $300. I think by the time it's all said and done, if you were only looking at exactly what needs to be used for what goes into this kit, probably somewhere between $500 to $1,000 to do sort of a conversion, not the R&D side. Each time I print a valve cover, it's a whole roll of PLA. Yeah, that might only be $12 at your local Micro Center or Central Computers or something like that. Um, but that's honestly what's taking more money is my personal time to do this, and then just the materials to keep printing iteration after iteration. Once I figure out things like the timing belt and the pulleys and stuff like that, a lot of that I can just take measurements online, and I don't have to physically buy the part. But when you're doing some of these little test fitting aspects, you it goes back to you don't know what you don't know. So like I had a print where it was just a little too tight of a tolerance, and it almost wants to touch something. And with heat expanding things and this and that, there's no point in me having it that tight. And so next iteration you add more clearance. So still, it takes time, it takes money. 3D printers are pretty efficient, but at the end of the day, you're still using electricity, you're still using plastic. Um, and with that being said, we're gonna hit the final elephant in the room, the compression ratio. I have a list for you people. This list is a little bit ridiculous. So, because I build BPs for customers, I have all of these pistons laying around if I wanted to use them. And so a really common setup that we build here is grabbing any of the 1/8 and using VVT pistons to give you the highest factory compression ratio possible. In the US, it's 10-1 for the NB2 Miatas, the VVTs. In Europe and Japan, they end up becoming 10.5. They have a slightly different piston. And so for a complete cross comparison, I decided to see what the worst case scenario would be. So that would be a European VVT piston with the M44 head. And with that and a 1 millimeter thick head gasket. And with that, you hit a 14.0 to 1 compression ratio. No, we're not running that. Going down the list now, NB1 with a 1 millimeter head gasket, 13.8 to 1. NA8 with a 1 millimeter head gasket, 13.1 to 1. Or a 1.2 millimeter head gasket, slightly over OEM, 12.8 to 1. Getting down into that 12.8 to 1 figure is probably the most comfortable I would feel here in California. We have, 91 octane, usually has about 10% ethanol in it. That's about the threshold I would want to deal with pump gasoline around here. And even then, the factory Mazda ECU is not going to be happy with it. Going back to what we were talking about of trying to run this off the factory ECU and being a fair comparison between everything, I wouldn't even consider this an option on a stock ECU. Maybe in future iterations in terms of sort of a pseudo high comp, I would feel fine running, that NA8 piston for a build. It does make it very affordable. You can easily find NA8 pistons or equivalent forged pistons at that dome level off the shelf. But we did a comparison even with 323 GTX pistons, which in factory format they're 8.8 instead of the 9-1 from the NA8, and even that's still 11.6. The only feasible comparison that we can run ends up being a SuperTech -4 cc dome, so it is actually bowled out type of piston. And between that -4 cc dome and running a 1.75 millimeter head gasket, and mind you, I ran that number just off the top of my head with the 1.75. Cometic offers a 1.78 millimeter head gasket, so this number will change slightly, but it is finally 10.5 to 1 with that thick head gasket with those very shallow forged pistons, where we finally have a fair comparison against a European or Japanese EVT. And I feel that's fair at that point because you can readily find dyno numbers for those cars. Should I want to build a second motor to do a true comparative test here? I can find those pistons, I can put it together, and everything will be happy, and we can have a true side-by-side. And the ECU will handle it. You can deck the factory Mazda heads 20,000s, and that will give you a little bit of a compression pump. So I know there's some room in the map to accommodate running that 10.5 to 1, and at least getting it started and going over some of the basics. So hopefully that finally ends the compression ratio questions. If anything changes and I have to rerun the numbers, I will let you guys know, but hopefully that's a very well thought out list and people can stop asking me about compression ratio. But I think that's it, honestly. I'm sure there's things I forgot along the way, but hopefully this gives everyone a really cool understanding of, what's going on with this, where it is, where it's going to go, and some of the little nuanced details in between. But yeah, I'm really excited for this. I know it might not necessarily show, but this is a really cool project. I'm really proud to be able to say that I'm the one doing this, and I'm really happy to have you guys joining along to see this thing come to fruition. I don't know when it's going to be done. I have some personal mental goals of things I'd like to do along the way, but life is ever flowing. And so I don't know when it's going to be done. I would like to be able to say, sometime in September, October, and that's being insanely optimistic, just because, I only have so much finite time to do design work, and it all depends on how smoothly certain things go. But yeah, this thing is really cool. And thank you guys again for sticking around, and honestly, my Instagram is blown up because of this thing, and I can't be more thankful. Thank you guys. I hate to sound like the usual YouTuber, but subscribe in case I make more updates on this. You can always follow the day-to-day progress or week-to-week progress on this on Instagram at rollerskate, RLRSK8T, just like this YouTube channel is. And I guess see you guys for the next one. Hopefully there will be some cool videos on this in the future. Peace.